Every time you push code to GitHub, a brand new computer is born, cooks your tests, and dies. Then it happens again, and again, 100 million times a month. GitHub Actions never reuses servers. It builds a fresh one for every job, like a pop-up kitchen demolished after every single order. Before 2019, CI meant pain. Developers manually ran tests, then manually deployed. Jenkins automated pipelines, but you hosted it, patched it, babysat plugins at 2 a.m. GitHub Actions flipped the model. Your pipeline lives beside your code, and GitHub owns every server. But owning millions of on-demand servers is a nightmare. Picture React's repo. 1,000 pull requests open right now, each triggering a workflow. If GitHub reused the same server for every job, one leftover file, one cached dependency could silently break the next team's build. Every job needs its own untouched disposable kitchen. Every single time, no exceptions. Here's the recipe card developers write. A YAML file defines triggers, jobs, and steps. On, push, says when to cook. Runs on, Ubuntu latest, orders a fresh Ubuntu kitchen. Each uses line pulls someone else's pre-built tool instead of writing it from scratch. This file is the entire contract. Here's what nobody tells you. Spinning up a fresh VM from scratch takes 2 to 5 minutes. That's too slow for 100 million jobs a month. GitHub's secret is pre-warmed kitchens. Thousands of idle VMs stocked with Node, Python, Docker. Assigning one takes 10 to 30 seconds, not minutes. Here's the full trip from your keyboard to a running test. You push code. GitHub's event system fires. The workflow is parsed, validated, queued. The orchestrator finds an idle runner from the warm pool and assigns your job. Total time, often under 10 seconds before tests execute. Under the hood, GitHub's Orchestration Stack has layers. An event system detects your push. A global job queue holds millions of waiting jobs. A runner pool manager matches jobs to VMs. This pipeline processes 1 million plus concurrent runner processes at peak, without you seeing any of it. Remember the pop-up kitchen? This is exactly that. An order arrives, your push. A kitchen is built, a VM cloned from the warm pool. One dish gets cooked, your job runs. Then the kitchen is torn down completely. No leftovers, ready for the next order. This system now handles staggering scale. GitHub reports over 1 million concurrent runner processes during peak hours. Across all repositories, that adds up to 100 million workflow runs every month, pulling from a marketplace of more than 20,000 reusable community-built actions. Nobody writes npm install and docker build by hand anymore. The marketplace is a shared recipe book. Actions checkout grabs your code, setup node installs node, docker build push action builds images. You just call the recipe. Someone already solved the boring part, 20,000 recipes for almost anything. But borrowing recipes is risky. @v4 is a moving tag. The maintainer could swap it for something malicious tomorrow, and your pipeline would silently run it with your secrets. Pin to the exact commit shay instead. It's the difference between a trusted recipe and an unlocked kitchen door. Real pipelines aren't one job, they're a chain. Needs test tells GitHub don't build until tests pass. This builds a dependency graph, a DAG, and GitHub's orchestrator walks it, releasing downstream jobs only when their parents succeed. Break the graph, deploy never fires by accident. One workflow can multiply itself. A matrix testing 4 Python versions across 3 operating systems fans out into 12 parallel jobs from one YAML file. Now imagine 1,000 pull requests doing that simultaneously. That's 12,000 concurrent jobs, and GitHub's queue absorbs it without blinking. Every kitchen needs a locked spice cabinet. Secrets are encrypted at rest using public key cryptography, decrypted only inside your workflow run, and never printed to logs. GitHub automatically masks any secret value with asterisks if it accidentally appears. Leak-proof by default. Not every secret should reach every kitchen. Repository secrets are available to all workflows in that repo. Environment secrets only unlock for specific deploy targets, like production, requiring manual approval. Organization secrets share credentials across many repos at once. Scope tightly, leak nothing. Here's the upgrade senior engineers use. OIDC. Instead of storing long-lived AWS keys as secrets, your workflow requests a short-lived identity token from GitHub. AWS checks that token, trusts it, and hands back temporary credentials expiring in 15 minutes. No static keys sitting in your repo, ever. Sometimes you need your own kitchen. A GPU, on-prem hardware, stricter security. Self-hosted runners solve this. Your machine registers with GitHub, then long polls the job queue asking, anything for me? When a matching job appears, it pulls it, executes it, reports back. Same protocol, your infrastructure. GitHub eats its own cooking. Every pull request to the Actions codebase itself triggers Actions workflows testing Actions. True meta-engineering. Microsoft reports teams adopting GitHub Actions cut deployment time by 60% company-wide. If it's good enough to build itself, it's good enough for your pipeline. Vercel uses this exact pattern for preview deployments. Every pull request triggers a workflow. Check out code, build the app, deploy to a temporary Vercel URL, then post that URL as a comment on your PR. Fully automated, zero manual steps, live in under a minute. Zoom out and the whole pipeline is one flow. Push triggers evaluation, jobs queue, warm VMs get assigned, steps execute using marketplace actions and encrypted secrets, results report back, all in seconds, all repeatable, all disposable. That's the entire engine behind 100 million workflows a month. In an interview, they might ask, why not just self-host Jenkins? Here's your answer. Jenkins gives full control but full ops burden. Patching, scaling, plugin security. GitHub Actions trades some control for zero infrastructure management, native YAML as code, and a marketplace of 20,000 ready-made recipes. The numbers behind the reliability. Warm pool assignment succeeds almost every time. Job start speed stays fast even at peak load, and the queue keeps absorbing spikes without operators touching a dashboard. That's what managed CI/CD actually means once you're running at this scale. Here's the part that surprises people. Ephemeral VMs aren't just about speed, they're a security feature. Because nothing persists between jobs, a compromised dependency in one build can't poison the next. Throwing away the kitchen after every order keeps 100 million monthly workflows from cross-contaminating each other. In your next system design interview, say exactly this. GitHub Actions treats compute as disposable. Every job gets an ephemeral VM from a pre-warmed pool, trading a few seconds of latency for total isolation and zero server management. That sentence signals you understand ephemeral infrastructure. Put it all together and you get one system. Developers push code, GitHub's queue and orchestrator route jobs. A warm VM fleet executes them using marketplace actions. Secrets stay locked in an encrypted vault, and self-hosted runners extend the same model to your own hardware. Scale this across every Fortune 500 company on GitHub, every open source project, every solo developer's side project. That's how one YAML file format quietly became the default CI/CD language for the entire software industry, 100 million times a month, and still climbing. Zoom back to the pop-up kitchen one last time. Every order gets a fresh kitchen, every recipe is shared, not reinvented. Every spice cabinet stays locked. And when the dish is served, the kitchen disappears, leaving zero trace for the next customer in line. Before your next interview, lock in these 5 ideas. Ephemeral runners, pre-warmed VM pools, job queuing at scale, DAG-based orchestration, and secretless Auth via OIDC. Say these 5 terms confidently and you'll sound like someone who's actually debugged a CI pipeline at 2 a.m. GitHub Actions is just one piece of the CI/CD world. GitLab CI, Circle CI, and BuildKite all solve the same problem differently. Some with tighter Kubernetes integration, some with faster caching. Knowing GitHub's model gives you the vocabulary to compare all of them in an interview. Every push you make now spins up an entire pop-up kitchen just for you. Built, used once, and torn down in seconds. That's how GitHub runs 100 million workflows a month without breaking a sweat. Subscribe for the next teardown. How Kubernetes schedules a million pods.